Alright, let's finish up these notes here. Last example that we're going to be working on. Holy cow, look at this thing. The example graph, -1 less than x plus y less than or equal to 3. We got two inequalities in this example. Don't worry about it. We're going to make this very, very simple for you. Alright, so how do you handle a double inequality like this? Well, just break it up. So what we're going to do is we're going to write down two different equations here that we're going to be, or I should say inequalities that we're going to be graphing. -1 is less than x plus y, and x plus y less than or equal to 3. So we just have to solve those two inequalities, and then graph each one, and then we'll actually just shade where they both occur. Alright, so let's get the left one, y by itself first. I'm going to completely flip the equation around. So I want the x plus y on the left side and -1 on the right. When I do that, I have to flip the inequality along with it, and then getting y by itself on the left, y greater than -x minus 1. Alright, so that's what we want. We want y by itself on the left. We now have an idea of what this line is going to look like. We know it's shaded because the inequality is just a greater than. I'm sorry, we know it's dotted because that the inequality is just greater than. We know we're going to shade above. Using my rule, that y is greater than means we're going to shade above. We could also plug in the origin and see how that works out. Okay, isolating y in the second one. So y is less than or equal to -x plus 3. Okay, so we have two different graphs here. I'm going to do one in blue. We'll do this one in blue here. And then I'll do the other one in green. Okay, so the first one, going to -1. And in order to graph this, I have to go down one, right one, according to the slope over here. Alright, so open dot because it's dotted. So starting at -1, open dot, down one, right one, another open dot. And then we're going to connect this up with a dotted line. Okay, and then the second one we're going to put in green. Okay, up to 3. 1, 2, 3. Another reason why I'm putting this in green is just to show you the difference between the two graphs. This is all part of one solution. Alright, so solid line this time, solid dot, solid line. And we're going to go again down 1 over 1. This time it's going to be a solid line connecting those up. Alright, now we have to decide where do we shade. Okay, so for the blue dotted line, I'm saying greater than. We should be shading above. Okay, so that would be all of this region, okay, including the green line. Then y less than or equal to says we're going to shade below the green line. So that would be all this region. So as far as I can tell, the part in between them is where they are both hitting each other. They're both intersecting. So let me go back here, clear out the shading, and go ahead and show you where the solution is using red. That would be the part in between. So that should be the part that satisfies both. Now we can again check using, as the video suggested, 0, plugging in 0 in for x and y. So we end up with 0 is greater than -1, and that's true. So the region above the blue dot line is going to work. I put 0 in here. It's 0 less than or equal to negative, I guess 0 plus 3. 0 is not negative or positive. Let's put positive. So 0 is less than or equal to 3. Also true. So again, the side below, or the origin side of the green line is going to work. So the origin side of the blue dot line and the origin side of the green solid line both satisfy this equation. So they both check out, and they both agree with my method of greater than or less than when y is by itself on the left. So as you can see, here is our solution. Nothing spectacular. All the points between those two lines, not including the blue one because it's dotted, but including the solid green one, are your solutions. Okay, I believe that's it. Let's check. Yep, that's it. That's all we have for this lesson, 1.8. I hope you enjoyed it.